Paul, it's over to you.
All right, so good morning, everyone, and thank you for attending our webinar on bridging the gap between IT and OT. So before we start, I'd like to think about a scenario. So picture two cities that are separated by a gorge with no easy way to get from one side to the other. Both of those cities were built independently for over many years, and for a long time they existed in isolation, each with their own views and opinions of how things should be done. And some might even say a little bit of rivalry between the two cities. Lately, both cities realised that there was benefits in crossing the gorge, so they decided to build a bridge. Now, in the first scenario, both sides decide to build their own bridge, but unfortunately, this results in waste and duplication. In the second scenario, both sides agree to build half a bridge, but unfortunately, they don't meet in the middle, and ultimately, that bridge has served no purpose. And in the third scenario, both sides work together to build one bridge they both can use. This is the bridge we want to build when integrating our IT and OT. So what are we going to talk about today? First of all, we're going to talk about why we actually want to bridge the gap between IT and OT. Then we're going to talk about how to integrate our IT and OT systems. And then finally, we'll talk about how to make it a reality. So why do we want to build this bridge? So let's think back to our example at the top, at the beginning, where we talked about these twin cities. And in this case, one of those cities is operational technology and the other city is IT. So let's start by looking at OT. Operational technology encompasses all the systems that control and execute processes on the shop floor. The priorities in that space include minimising downtime and delays, prioritising safety of the plant and efficiency. It requires an in-depth knowledge of the equipment, processes and technologies used that are very unique and specific to that operation. And often devices in the operational technology space will remain unchanged for a long time. It's very much a mentality of if it works, don't change it. Now, if we move across the gorge to the space that's occupied by IT, we have IT who manage the laptops, desktops, servers, networks, and business applications throughout the organisation. Their priorities are cybersecurity, scalability, and manageability. And IT has a broad view across the enterprise that encompasses data, computing, networking. And often change happens quite a lot with security patches and upgrades being applied on a regular basis. So why is there a gap between IT and OT? And the reality is there's a number of differences, so let's explore those. First of all, IT believe that operations don't follow best IT practices. IT believe they've got a better understanding of core technologies such as cloud computing, networking, and databases. And IT are often accountable for cybersecurity within the organisation. Let's move across to OT now. So OT believe that IT don't understand the challenges of running a manufacturing business on a 24/7 basis. They have devices that simply aren't seen in the office environment, things like PLCs, VFDs, and sensors. These are very alien to IT people. And also, those OT solutions are starting to become more and more like IT equipment. And from both perspectives, they've got different operational priorities and approaches to risks. And again, both sides have a lack of trust with each other, lack of communication, and sometimes they end up actually competing, doing very, very similar tasks. So why do we want to go and bridge this gap between IT and OT? First of all, having a siloed approach means that data can't easily be shared from the shop floor to the top floor of the organisation. And often necessity is the mother of invention, often at the cost of cybersecurity. And people will do things like using USB sticks to manually move data between systems, but this can create problems. If that USB stick gets lost, that data goes with it. Equally, USB sticks can be a good source of viruses and a way to bring those into the organisation. And we can also think about how we can secure remote connectivity to machines to monitor usage and diagnose problems. Those are just some of the examples of why we might want to bridge the gap between IT and OT. But why are we doing this now? From 1760 to the present day, manufacturing has been on a journey through a series of industrial revolutions. Each of these was marked by a piece of enabling technology. In the first industrial revolution, we went from hand production methods to machines. The enabling technology was steam and water power. In the second industrial revolution, we saw the introduction of mass production and assembly lines. The enabling technology was electricity. In the third industrial revolution, in the 1980s and the 1990s, we saw the rise of automation. The enabling technologies were computers, PLCs, and robotics. And the fourth industrial revolution, where we are today, sees the physical and digital worlds working together in harmony. There's a range of different enabling technologies, from additive manufacturing through to cloud computing, machine learning, and the Internet of Things. So what is a smart factory? A smart factory is about continuously collecting and sharing data through connected machines, devices, and production systems. That data can be used across the organisation to proactively address issues, improve manufacturing processes, and respond to new demand. And by connecting the physical and digital worlds, smart factories can monitor the entire production process, from manufacturing tools and the supply chain to individual operators on the shop floor. Simply put, a smart factory is about making the best decisions in the shortest possible time based on the most accurate and actual information, where those decisions are made by people, automated machines, or cyber physical systems. So, as we've talked about earlier, each industrial revolution was marked by a series of enabling technologies. Let's have a look at some of those in a bit more detail. First of all, we've got the industrial Internet of Things. IoT is not just about sensors that are acquiring that data, it's the end-to-end process of getting data from new sources and existing sources and turning that data into actionable insights and responses. And to support that, we use things like cloud computing and edge computing. We can move a lot of that processing into the cloud, where we can take advantage of economies of scale. Where there's a lot of data to be processed, that can happen locally with edge computing before we move it to the cloud. We can use analytics and machine learning to process that data and gather those insights and determine what the best course of action is. And we can also use digital twins. We can simulate what would happen. We can model how particular things might play out if demand increases, if a machine breaks down, if we make a change. We can do all of that through the use of digital twins. So how are we going to actually integrate our IT and our OT systems together? First of all, it's going to start with connectivity. Smart factories are highly connected, and we need to integrate both our IT and OT networks. And those networks need to be reliable and have sufficient bandwidth. We also need to think about cybersecurity without connecting environments that may never have been connected before. And to do that, first of all, we need to think about how we're going to identify our digital and physical assets and think about how are they interconnected, what has access to the internet, what has remote access, who can do certain things on those devices. Once we've identified our devices, we need to think about how we can protect them and how we can mitigate the effects of a possible cybersecurity incident. It's often best to go and have a multi-layered defense. So rather than relying on a single control to defend a particular asset against a cybersecurity threat, if we take a defense in depth approach, even if one defense fails, other defenses can step in and prevent that cybersecurity attack happening. The reality is, though, we're never going to be 100% successful in defending against every cybersecurity threat. And we need to be able to detect when those threats do make it through our defenses. And that can happen using continuous monitoring to look for unusual activity and other threats. And once we've detected an event, we need to think about how we're going to respond. That could be automatic, or it could be manual action to respond to that issue that we've just detected. And then finally, we need to think about how we're going to recover. How do we return to that business as usual state? And also, how do we stop similar issues happening again in the future? Now let's think about the data sources. So on our IT side, we've got a number of different sources. We've got our supply chain. We get access to external systems that may be our logistics systems. It may be incoming parts, so we know when they're going to arrive. It might be specifications. Equally, we've got a number of enterprise systems within the organisation. That could be our ERP system, our MES system, our PLM system. And on the OT side, we've got our human operators who may be equipped with handheld scanners and tablets. So this could be entering information about the products that have been produced rather than relying on paper processes. We can move those to tablets and scanners. And also we've got the things on our factory floor, whatever's producing the products the factory is making. So we've got a number of sensors and machines. They can all supply data that we can use as part of building the smart factory. Now we need to think about how we're going to integrate all of these different information sources. And in Industry 3.0, sort of in the 1990s, and maybe even the early 2000s, we had a very hierarchical approach. We started with our ERP system at the top, and that would feed data down through to other systems, to our MES system, which would then talk to our PLCs, which then look at the sensors and then the physical process. And that, I think, was probably appropriate at the time, having this very layered architecture. But what it does mean is it's very difficult to get data from one system to another system very quickly. And equally, businesses have introduced a number of new technologies that don't fit into this model. And what we end up with is an integration pattern that looks something like this. It's very chaotic. We've got lots of system A talks to system B, talks to system C. And if you want to make an upgrade, it's very difficult for you to think about all of the different knock-on effects that can have. And that really does start to hold businesses back as they want to build the smart factories of the future. So with Industry 4.0, we take a new approach to how we're going to integrate all of these systems. So rather than having that layered approach that we saw in Industry 3.0, with Industry 4.0, we've got this hub and spoke model. We have this unified namespace where all of our data gets fed into. This is the repository. And our spokes, we've got all these different sources that might be producing data or might be consuming data. That could be the machines, it could be our ERP or our MES systems, it could be dashboards that display information to our production leaders, to management within the organisation. And it could be things like our Internet of Things that are actually supplying data from new sources that we didn't have access to previously. So how are we going to make this a reality? There's a number of steps that we need to take. First of all, we need to think about the goals and requirements. First of all, we need to understand what the business goals are and what the business needs to achieve those goals. Next, we need to think about our desired outcomes. And we also need to define the requirements to achieve those outcomes. If we don't define the requirements and what the acceptance criteria is for those requirements, it becomes very difficult to know if we're heading in the right direction, if we've actually met the objectives that we set out to do so at the beginning. And often it can be useful to think about where we can obtain the biggest business benefits quickly, and that will help get some early wins in, and then it becomes easier to go and support the product or the program of works as it progresses. Next, we need to think about stakeholder buy-in. We need to identify the stakeholders. A smart factory journey is going to have a lot of different stakeholders, from operators on the shop floor through to production leaders, quality, maintenance, people in the office space, our purchasing department, our accounts department, our management. All of those are going to have an interest in this new vision that we're trying to deliver. And often it's best to start from the top of the organisation and work down. So win support with the management first before going down throughout the organisation. And I think it's also important to think about the benefits and explain those to stakeholders, but equally be receptive to feedback. We may start with one vision of how the smart factory should look, but all of our other stakeholders are going to have their own viewpoints, and they need to be incorporated into that final vision. So once we've got our requirements, once we've got our stakeholders on board, we need to think about our architecture, our design. What is the smart factory actually going to look like? How are we going to design it? And that starts by creating a solution architecture. And that solution architecture, just as if we're building a house or a building, says what that building, or in this case, a smart factory, is going to look like. It's going to outline the vision. What is it going to do? How is it going to do it? We then need to think about creating a roadmap to deliver incrementally. Smart factories is a complex transformation. It's not one single change that will get us there. There'll be a series of incremental projects delivered one after another that will gradually build on top of each other to deliver those business benefits. So if we create a roadmap, we can start by looking at what's going to give us the biggest benefits straight away, and what dependencies do we have that need to be met before we can deal with some of the phases of the program. Next, we need to think about our networks and cybersecurity. As we mentioned earlier, smart factories are highly connected. We need that connectivity between our OT and our IT environments. So we need to have an operational technology network. Some businesses have that already. Others have a very fragmented view on the shop floor with individual cells or machines connected to their own little networks. But what we need to do is create one network that spans the entire shop floor so we can integrate that with the rest of the organisation. And we need to think about baseline standards. If we're connecting all of these devices that were never previously connected before, what are the requirements to be on board to that network? Things like antivirus, patching, all of those security controls that we need to ensure we're protecting the environment correctly. We need to think about these layered cybersecurity defences we've talked about by having multiple defences in line with each other. Even if one fails, hopefully another one will step in to prevent that attack being successful. And once we've got all of our infrastructure in place, we've got our networks, we've got our cybersecurity, we can then start to think about the delivery. And that starts by connecting the machines and production systems to the OT network. We then need to build this trusted integration platform for sharing that data. We talked about this hub and spoke model. This is about building the hub, the repository where all the data is going to be stored so it can be accessed by our producers and our consumers. And then finally, we integrate these producers and consumers of the data with the platform. So what are the challenges? Any smart factory journey is going to be a complex transformation, not going to be something that is going to happen without its own challenges. What might they be? Legacy devices is a good one. So many factories have equipment that ranges perhaps from the 1960s and even earlier. It can be difficult to integrate those into a modern smart factory, but nevertheless, it's not impossible. We just need to think about how we can get the data from those machines and get the right balance between data and security. Sometimes trying to do too much too soon, it can be tempting to try and get all of the benefits from the smart factory in a very short space of time, but that can be a problem in its own right. Instead, it's better, as we said, to go and try and do things in small steps with increments that we can show small business benefits straight away and build on those, rather than trying to have this big bang where we get everything done in one go. And people and processes, it's very easy to think about technology when we're building a smart factory, but ultimately people and processes must work hand in hand with the new technologies that we're introducing. So we need to make sure we get the stakeholders on board and we update our processes to work with that. So what have we covered today? So first of all, we talked about why we want to build a bridge between IT and OT. We talked about some of the benefits in terms of why smart factories is the way of the future. We also talked about the practicality of integrating our IT and our OT systems together. We talked about networking, we talked about cybersecurity, we talked about integrating our data. And then finally, we talked about how to make it a reality. We talked about these 5 steps, starting with understanding the outcomes that we want to achieve and the requirements, and that ended with that incremental delivery of a series of projects to build that smart factory. So what I'd like to do now is open it to the audience and see what questions you have.
There's nothing coming up in the chat feature. Dare, not sure if you've got any questions that you'd like to put to Paul. If nobody's got any questions right now, but after kind of going away, listening again, then obviously you can always email Paul at info@ripleysolutions.co.uk. You can reply to that email, or you can also find him on LinkedIn as well. So yeah, there's no escaping from Paul for the questions, I'm afraid. But yeah, but if we haven't got any questions, if I just hand over to Paul to say his final piece.
Yeah, so thank you. So in terms of what next then, so Ripley Solutions, we can help you bridge that gap between IT and OT. As Ruth said, please feel free to connect with me on LinkedIn. I'll be happy to continue the discussion with you offline, or alternatively, visit our website, ripleysolutions.com. Thank you.
Excellent. Thank you very much, Paul. I'm going to close the session now and stop